Hey guys, welcome to the channel. My name is Manoj Singh Negi, and today we are going to continue building a shell in C. If you haven't checked out the first video, I'll highly recommend to go and watch that video before watching this one. Today we are going to be expanding upon what we did in the last video, implement a command history. So you will be able to go back and access all the commands that you executed using your up and down keys. So let's get started. So to implement history, I'm going to go here and create a variable which will hold our history, right? But before that, let's define some parameters. So I'm going to define the max history because we don't want our program to get bulkier and all that. So I'm just going to define a max history. So at a time, our shall only be able to hold 100 commands. Okay, and those 100 commands will have a max command length of 1024 characters. Okay, so we don't want commands to have more length than 1024. Right, let's define our variable which is going to hold our history, right? So what I'm going to do is I'm going to define a 2D array. So 2D array, a static 2D array, because we want this to be used by every function. So static char history with one dimension being the max history, right? And the second dimension being the command length, right? So max command length. So here is our history variable. So we have two dimensions. The first one is like basically the max history, the indexes of the history, and the second is this command length, and this will be basically the in every index how much of length a command is basically. And then I'm going to define two other variable. Um, First one will be history count. So what is the count of the current history? How many commands are in the history right now? And then I'm going to define current index. This will be what index we are in. So for example, if we tap up or down, what index we are in, and according to that, we are going to show the, whatever the command is in that index and move up and down, right? Now let's write another function which will add to history, right? So whenever we execute a command, we want to add it to history. So let's define a function for that. Void add to history, and it's going to take the command, right? So I'm just going to say char const pointer command. The reason we are saying const is because we don't want to modify that command, right? So this is why it is here. So we're going to now we're going to basically check if we hit the uh, maximum history we can save, right? So I'm just going to say if the history count is less than max history, only then add to the history, because if the history is basically full, we don't want to add to the history, right? So history count max history, then we're going to copy the our command into the index of the history variable. So let's do that. Stun copy history count. So you can see like by default history count is 0. So if we have no commands, then it's gonna go to the 0th element, right? So the next will be what we want to copy in this. So obviously command. The other will be the length we want to copy, and that will be command. Like this, it should not be more than this, right? If the command is more than that, then we are just going to cut it off and then just copy the part that fit the max command length, which is 1024 character. So if the command is more than 1024 character, we'll cut it to 1024 and then save it inside the history variable, the indices, right? Next we will do is null terminate this index. So we're going to do history count, and command max command length -1 will be equal to a null terminated screen, because we don't want we want to tell the compiler that, this is where the string ends, um, here, right? So, and the other thing we're going to do is we're going to do history. We're going to write history count plus plus, because now the history count index is 1, not 0. So history count becomes 1. Now, whenever there will be a second command, it will be saved inside 1, and then there will be a third command, it will be saved inside the second index of the string. Another thing we're going to do is we're going to set the current index equal to history count, because that makes sense, because current index, whenever you type a new command, should be the latest. So for example, if you're typing your 99th command, the current index should be 99. So whenever you will press the up command, it will go to 98, 97, 96, right? So we have this. Now this is add to history. Now let create two other functions. First one will be get history up, which will basically get the history upward. So for example, when you press the up button, it will go from 98 to 97, 96, 95. And one function will be get history down, which will be when you are at, like, for example, you are at the 99th element, you go 98, 96, 97, 98, 96, 95, 94, and when you press down, it will come back, right? So we have these two commands. So let's write these functions. So the function will be char, also const, because whatever they written, we don't want to modify. So const char, it will return a char, which will be, whatever the command at that index. Get history up, right? And then here we have to check if the current index is greater than 0, because if it is 0, then we don't want to go down, right? We don't want, because 0 is like the last index, and if we go down that then it will become -1. We don't want to do that. So we're going to do if current index is greater than 0, then we can do this current index minus minus. So we will basically bring the current index down by 1, and then return the command at that index. So history current index, and that's pretty much it. And if if it reaches 0, then just return null, and that's it. Like, we don't want to do anything, right? Now let's write the down, get history down function. Again, this also return char. So get const char get history down. If so, get history down. Now, here we also have to check for a condition, and the condition will be, what if you are at the last element, right? Like, if you are at the last element, then you can't return anything more. So for example, if you have 40 commands, you can't return the 41 indices. You have to return an empty string, right? So that's what we'll do. Another thing we need to check is if the current index is more than the it can't be more than the history count, right? So for example, if you have 40 command, it can't be more than 40, 41, 42, 43, right? So we're gonna say if current index is smaller than history count -1. Yeah, because it can't be greater than history count, right? So if we just check for history count, then if we do +1, then it will become history count, and we don't want to do that, right? So current index, until it is lesser than history count -1, we will uh, increment it by 1, and then return the command at that point. So history count, right? And else, if that's not the case, if it is greater than or equal to history count, that means we are already at the latest. At that point, we will just um, return the empty um, string, but we also set the current index equal to history count. So it doesn't go it doesn't go outside the history count, right? So the reason we do that is because so it reset to the latest index, right? So for example, if you are just tapping down, 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 it will always reset to the current index, right? So we have get history up, get history down. One extra utility function we can write is print history. So, even when we don't have the up and down mechanism, we have to implement that later. But I can just write print history and then it will print the whole history, right? So let's do that. Void, void print history, and then I'm just gonna run a loop for int I equal to 0 and until I is smaller than history count, just keep doing I plus plus. And then I'm just going to print the, whatever the command there is. So percentage s and new line. So there will be a new line between each command. And then just history I, and it's just going to print the history. So good, that's great. Let's now work on actually saving the commands, right? So let's do that. Um, so what I'm going to do is, once we know the command is valid and everything, we are going to save it inside the memory. So let's do add to history and just pass input into it. And this will basically, save the input inside the history. Now let's compile this. It is compiled. Great. Now let's run this TinyShell and we have our shell. Great. Now let's, just execute some command ls-la ls pwd which pwd, right? And now type print history and it says no just file or directory because we haven't implemented that command. Just like we did exit in the last video, we haven't implemented that command. So we have to implement that command. Just gonna do it here. So if string compare the input with print history, and if it matches, then call print history and break and continue, not break. Break will only happen when we exit because this is a while loop, never ending loop. We don't want to break, we just want to go to the next iteration. So I'm just gonna exit, compile this, run this again. ls-la pwd man ls, right? Now let's type print history. Okay, so now it works. You can see ls alpha pwe and also print history because that is also inside the history. Um, and that is great, right? So our history is working. So we are saving these command into our history and we called print history, and print history basically printed the history, printed all the history, right? So that's great. Now we have to implement the up and down key because right now when you can see, right, whenever we type up and down, it shows something like this. And this is the reason because right now our input is handled by the terminal. So for example, fgets, right? We don't want to do that. We want to handle each character. So each character um, by ourselves, right? So right now all of the like backspaces, all these keys and everything is basically controlled by the terminal, right? We want to control it. So for that we have to enable something called raw mode. So let's do that. So let's go here and I'm going to write a function called enable raw mode and another which will be disable raw mode, right? So let's get started on that. So void disable raw mode, right? And then we'll have another which will be void enable raw mode. So we have the disable raw mode and we have the enable raw mode. So to modify the settings of the terminal, so we will be able to handle all the input by ourselves, we are going to use TermiOS utilities. So, and you will find TermiOS utilities in all POSIX compliant operating systems like Linux and macOS. Now let's define our variable. I will go here, say static struct TermiOS, TermiOS, and then the name of the variable. So I'm just going to say original TermiOS, right? Just like that, we have to import TermiOS. So let's include TermiOS.h. So this will be the variable where we will save the original settings before we enable the raw mode. And then we will use this variable when we will disable the raw mode to, disable, like go back to that original setting. So for disabling the raw mode, I'm going to use something called um, TC set attribute. This is basically a terminal set attribute. The first will be where we want to set the attribute, which will be std file number, which is basically the the our input, like here, our input, right? And the second thing will be tcsa flush, and this is basically telling the tc set attr function that do not worry about any pending settings or anything, just immediately apply the settings and override the setting that I'm providing. And because this will be the original settings that we will going to be using, I'm just going to pass it as the pointer, the reference of this, and this will basically disable the ROM. Now, when enabling the raw mode, we want to um, fill this variable. So save all the settings at this variable. To do that, I have to call, just like setItter, we have getItter. So tc get utter, again, std in file number, in file number, and then termi in place of this, again, reference of TermiOS, and this will basically, whenever we enable the raw mode, save all the setting inside the orig TermiOS variable. Okay, and the next thing we are gonna say is at exit call the disable raw mode, basically, right? So whenever we will exit out of this thing, then just disable the raw mode. Just call the disable raw mode, and that will basically bring everything back in case, whenever we exit. All right, that's great. Now we are going to actually define our settings, and the settings that we want to disable is firstly is echo, and then the other thing is canonical settings, because echo, what echo do is, like, whenever you type anything, it outputs that to the terminal. Like, if I type ls, then it outputs to ls. If I keep doing up, 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 down, 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 that is, then again, it's typing to the terminal, and we don't want to do that. We want to control this and only output what we want to, only show what we want to show, right? And the other is canonical. Canonical is basically, it parses the input as a line. So it waits for the line, and then you hit like enter, and then it passes the line. We don't want to do that. We just want to um, process every keystroke. So if I press up, up, down, down, I want my program to process that. Okay, so we are going to disable that. Let's first define a struct termi OS. This will be the raw settings. Firstly, we get all the original settings. Then we're going to say raw.c flag bitwise operator equal to echo and I cannot. So what this line do, it basically flip the bits. So these are bits and we just flip the bits of it and just enable to disable, right? So we disable both of these mode. You can, maybe research more about how this works. But basically what this line do is disable the echo and canon mode. The other thing is raw.cc, again, another flag. We say v min equal to 1. This basically says only wait for one character, right? So as soon as one character is written, that's it, right? Just return. And then raw.cc again, v time equal to 0. That means basically don't time out, right? Like wait indefinitely for the input, right? So um, don't time out. Like even if I'm not typing anything or anything like that, don't like time out. Just wait for user to type, basically, right? Great. And then we basically set this as the uh, attribute. So t c set attribute again, std in file number, then the again tc SA flush, so it applies the setting immediately and overriding everything else. And then the basically the pointer, which will be end raw. That's pretty much it. So now we are able to enable the raw mode. Now every keystroke that we type, like ls, um, will be interpreted as individual character. So previously, if you look at this, we had input, we were reading it in one line, right? So whatever you type, input and hit enter, and that was being treated as the whole input. Now we will have access to all the characters, right? So now let's read characters one by one. So I'm going to define a function called void read input, and this is basically going to read the input and do things according to that. Void read input, and we are going to pass a buffer. Okay, pass a buffer, and then we are going to do operation on it. So the buffer will be our input basically, which will be like an empty buffer, and then we will be basically intercepting all these character and then filling our buffer, and then according to that again execute all this command. So basically what we are doing is we are replacing this fgets, handling the processing of input by ourselves and handling the responsibility of also filling the input. So let's get started. Before we start, we don't know what is the length of the buffer is going to be. It can be 1 character, 2 character, 3 character, whatever. We are going to read read the characters line by like character by character, but the buffer will be like the and command, you can say, or whatever the user writes and hit enter basically. But at the start, we don't know. So we are just going to say int. We are going to define a length. We're going to say int length equals 0. And then we are going to null terminate the string. So we're just going to say buffer is empty right now. So it's an empty, right? So it's an empty string basically. The other thing we're going to do is we're going to enable the raw mode. Now we are talking. So, okay. So we enable the raw mode. Now what we are going to do is we're going to read the characters one by one. So for that, we are going to define a char C, right? In this, we are going to read everything. And we are going to run a while loop, character by character. We are going to need a while loop. So I'm just going to say while loop and read the std in file number into the character. The byte size will be 1. So because we are reading by one, and if it is equal to 1, that means it is success. Then we we'll keep just reading it, right? And at the last, we will disable the raw mode as well. So because we don't want the whole um, like other commands and the whole functions to get affected by what we are doing. So we're just going to disable the raw mode. All right. So we're going to say if C equals to a new line, if it is equal to a new line, break. Because when you hit enter, that means that is the end of the command, right? So the loop will run until you'll type ls hyphen al. So every character is a new iteration, like a new iteration of the while. But as soon as you hit enter, this will be basically, end the command and just break out of this, right? We'll break, but before breaking, we will do this. So buffer lan equal to a null terminated string, right? And we also print a new line, printf. So what we are basically doing is whatever the length. So for example, we are going to run a loop and we're going to keep incrementing len. We'll do it later in this loop, but we'll just say len equal to 1, 2, 3, 4, 5, 6, and then whenever you hit enter, we just add the buffer there and tell the compiler only read these 6 characters, and that's it, right? And that will be our command basically, right? So this is when if this is if we press enter or you know add a new line. The next will be what if we hit backspace. So for that we're going to do is either C equal to 127, which is the ASCII of backspace or delete, and what either that, or you have slash B, which is again um, represent backspace. If you do that, we're going to say if len is greater than 0, because if the length of this command, you can see here, is greater than 0, then only we can do this. What we are going to do is if len is greater than 0, we're going to do len minus minus. That means minus the length. So character is still there, but minus the length basically. And then say buffer len equal, again, null terminated, right? So compiler knows that there is no character anymore. So basically like this. So now it will be read like this. And now you can see like all of this works, right? But this works because we are not in the raw mode right now. So once we are in the raw mode, we have to manually handle all of these things. Right now this is handled by the terminal. All right, so do this. Then we are going to actually write the backspaces. So we're gonna say slash b space slash b, and I'm going to explain in a bit why we do that. But before that, we are going to flush to the buffer. Std out, right? So it will be buffer to flush to the input, right? The reason we did slash b is very simple. So what slash b does is it moves the cursor. Um, for example, if you have, let's say, ls hyphen la, it when we print slash b, the first slash b, it moves the cursor here. Then you say space. You can see the space here. That means remove this and replace this with a space, basically. And then again slash b, which will again move the cursor here, move the cursor here, and then in the terminal you will see something like this. All right, I hope this is clear. So again, just to revise, len minus minus, because we want to null terminate it, you know um, whenever you type a backspace, we decrement by the length of the buffer by 1. We null terminate it at that length. We print slash b to move the cursor, and then we flush it to the to the terminal where you are typing. Now this is all good, but we still don't handle up and down, and we are just going to do that now. So else if C, so right, like when we do up, you can see this, right? Or down, you'll see this. So now we are going to see else if C is equal to 27. 27 is basically escape sequence, which is this right here. If C is equal to 27, then we are going to read two more sequence, which is this, the bracket and the A, whatever the character A would be. So char sequence, we create a string for of like length of 2, because we're going to read into it, and we're going to say if, and then we're going to read like this. So we are just going to read if read std file in, instead of C it will be sequence 0, right? Sequence 0. We just have to read 1 byte equal to 1, and then we read the first sequence. Now we're going to read the second sequence, 1. So we read that into the sequence 1. Now both of these sequence, like bracket and A, is inside the sequence. Now we're going to say if sequence 0 is equal to brackets, right? That means, it is like either up and down command. Then we are going to do this. If sequence 1 is equal to A, you can see here, equal to A, then we are going to do the, up logic, and else if the sequence 1 is equal to B, then we are going to do the down sequence basically, right? So let's do that. All right, so in order to do that, first thing we need to do is basically get that command. So we're going to call that function get history up that we created, because whenever you press up key, you need to call that function to get the previous command, right? Let's do that. Const char, because you can't modify this command. Const char cmd, or I can say previous cmd, and that will be more descriptory. So previous command equal to get history up, right? And if we get that command, first and foremost, we're going to clear the buffer. So let me show you what I meant. So for example, if you type ls-la, and if you hit up, I have to clear the whole ls-la from the buffer, right? Because it is still in the buffer because you basically typed it in, right? So I have to remove that. And to do that, I'm just going to use the backspace, right? So what I'm going to say for int I equal to 0 until I is smaller than length, because whatever you type, buffer have that length, because we are basically incrementing that length, right? We are incrementing that length. I know that we haven't reached that point, but we will eventually. But yeah, so just suppose that we are incrementing that length on each key stroke length, and then I plus plus until and then until you just print f the /b/b, and that's basically going to clear the whole um, command, right? Now once that is done, we are going to actually write the command to the buffer. For that, we are going to use sprintf. So, and it's going to return the length. We need the length because we are going to save that inside the buffer. So length equal to sprintf, and then from where we want to copy and from where we want to copy, right? Printf, the other thing I'm gonna type here is max input. So max input is basically same as max command length. You can use max command length, but we are going to use max input. The reason we are using max input is that it should not go beyond this. And then just like we do in printf, %s, and then from where we are copying, previous command, right? Yeah, so the reason for this issue is we have to use snprintf, not printf. And what snprintf do is that it also take a max input, right, and cut off the string till there. And so yeah, I mean, so we get the length, we also copied it to the buffer and everything. We know the length now, and we are just going to print that to here, right? So for example, if you look at our history, if it's print history, you're just going to remove everything and just going to print that into the output, right? So let's do that. Printf percentage s, and we're just going to say previous command, and it's going to write, not previous command, sorry, the buffer, and then it's just flush it to the std out, std out. Great, so this works. Great, now let's implement our down key, right? So again, const char, because the get history down also do that. I can just say next cmd here get history down, right? Now here again, we'll do the same thing, which will be just remove whatever we have in the pipeline, and then we are going to do things. So the thing with the history down is it can return two things. The first thing is the command, and the second thing is empty space, because you can be the last or whatever, right? So in that case, we are going to do if there is an cmd, right? If next cmd, then we're going to do the same thing, length printf print that. We're just going to change it to next cmd. Else, if it is not there, or there is like this empty string, because it is empty string, we are going to just say length is equal to 0, because we have to decrease the length, and then buffer 0 equal to null terminated, right? Instead of 0, I'm just gonna put length, because that is much more explanatory, that we always null terminate the buffer when until the until that length, right? um, that's great. Now just output it again, empty the std out. Great, so this is looking pretty good. But now there is still one thing, which is we are not handling anything else than the new line, the backspace, and the escape sequence, which will be digits and numbers, right? Which will actually make up the command, right? So what I'm going to do here is else if, and at the end else, right? If length is less than max input minus 1, which makes sense because we don't want to go over the max input, because we have a uh, limit, right? 1024 character. Until then, just keep updating the buffer. So length plus plus equal to c. So if length is 0, then input the c into it. So for example, we type L, it will be saved inside buffer 0. Then we type S, it will be saved inside buffer 1, because we are doing a plus plus after we are setting the character. And then we will just write to, we can also use like printf and flush, but yeah, I mean, we just, let's be more professional about it. So we're just going to write into the std out file number, the buffer, which is the character. So right, and then byte 1. So the other reason we are not using the printf is because we mostly use printf when we are rewriting the whole thing, right? So for example, in up and down, but in this case, we are just outputting like one character. So it's just outputting, just keeping whatever there in the screen, and just writing, one more character into it, and then disable the row mode. I think we are pretty much good to go. We just have to call this read input in our main TinyShell function. Instead of fgets, we are going to basically call the read input, right? So let's do that. We'll just say read input into the input, right? So what we are basically doing is, so previously we had fgets, which was modifying our input, but now we are modifying it. right? So we are taking this buffer and modify. So buffer is basically input, and whatever we are reading, we are just pushing inside the input. So input will work the same as it was working before, right? Now also we don't need to do this because we are handling the new line. This was basically, whenever you find a new line, null terminate the string, so we don't uh, have the new line and all. So this works again. Now the only thing we need to do is check if it is empty. Because if the buffer is empty, or it's just for example, if I just hit enter, the buffer is going to be empty because that's what we did here, right? Like if it's just new line, null terminated, and if you haven't write like any word before it, so len will be 0. That means just null terminate at 0, right? So we don't want to basically waste any processing in that. So I'm just going to say if stir len input is equal to 0, right? Just continue the loop and wait for the next one. Let's see if all of this works. I'm going to exit. It compiled all right, which is great. And let's the moment of truth, TinyShell. We are in ls hyphen la pwd, which pwd curl whatever. Now I'm gonna press up key, and you can see the command. I'm gonna press which pwd and all that, right? Curl which pwd. Okay, so there is a issue. So if I tap down from ls, it just directly goes to the empty string, which it should not do, right? It should find the uh, last command. So if I do print history, you can see this. If I go up, print history curl which pwd, but if I just go down, ls hyphen la, it just goes there. What this means is that our current index stays the same. Even when I'm hitting down, it stays the same, right? Like you can see. So, okay, that is interesting. Let's find out what's the issue here is. Now I figured out the issue. The issue is that once you hit enter, you want to reset the history current index, right? Because what is basically happening, just like you do add history, right? So for example, I'm gonna exit, gonna go inside ls pwd, uh, you know, less whatever, and now you know that whenever I press up, it's gonna go to less because we are doing this current index equal to history count. So whenever the history count is updated, we set it the current index, right? But what we are not doing is whenever I hit enter, right, after that it should reset as well, because once you hit enter, you are basically should be at the end of your history, right? So we are not doing that, and it's basically keeping that. So what I'm gonna do is here I'm just gonna say history, not history, but current index equal to history count, like always whenever you read the input. And read input is basically whenever hit enter and then it start reading the input, right? So exit, compile it, go inside it, ls hyphen la pwd less, and I go less pwd or whatever. If I so I figured out the issue, and the issue is this, right? So we are always returning the history count, not the current index, and we have to return the current index like from here. So let's compile and see if that fixes the issue. So ls hyphen la pwd less pwd ls l, and you can see, right? And this works. Also backspace and everything work, you can see, right? And yeah, that's pretty much it. So we implemented the history and also the up and down navigation in this video. I'm going to create more videos where I will implement shell variables and pipe directions, right? So yeah, I'll see you guys in the next video then.